Well, I'm going to give you a tour of the whole system right now. There's a whole field, very interesting field called systems integration that basically shows you or goes through how to integrate complex systems. Integrate meaning making them whole, making a system out of separate components. And all the videos so far have focused on the uh, the sort of the flying component, the hardware, the machinery, the balloon gondola or cockpit, whatever you want to call it, but the controls, the pressurization of the suit, that kind of thing. And right now that sits over here. I'll show you that as it is right now. And turning over here, okay, you can see the whole system. You're familiar with this if you've watched the videos, and you can see I've painted a lot of it black to reduce visual clutter. The controls are all in place. A video I did just a couple, or maybe a week ago, showed all the gas systems working. So that's that system. Over here, there's a sheet over there, just sort of a dust cap. But so that's that system, and the suit is there underneath the dust cover as well. And that's coming along well. But there's a whole other system, which is control. And of course, there's control of the balloon itself, but there's also control from the ground. And making sure that the system works from the ground requires communicating with somebody who's talking on the radio. And they'll be monitoring what's going on during the flight with instrumentation that's sending telemetry, basically signals about the state of the aircraft down to the ground, feeding it into a computer, and then they kind of read what's going on in the computer. But to begin integrating all that, to begin connecting all of those things, I need to simulate flights. I also need to do that so that I get a lot of time in the suit, pressurized, and so on, and communicating with somebody on the radio. So one way to do that was to begin by writing a flight simulator software. Now, using very basic physics, Archimedes' principle, Boyle's law, a couple of other things, I was able to write a program. I learned programming a long time ago on this old Macintosh, and it works just fine, and I'll show you the simulator program going here in a minute. But basically, using some basic formulae regarding the properties of gases and buoyant forces and that kind of thing, I start with those, encode all of that into the programming, and then run the flight simulator. I'm also then integrating all of that, what's going on in the simulator, and presumably what's going on sort of in the balloon, into a flight manual. And this is something that describes all of the properties of the components of the system, and then how the whole thing flies. I'll have to be intimately familiar with, in terms of memorization, everything in the flight manual. People on the ground very familiar with it, but they'll also have it on hand. I won't have time or the ability to mess around with the flight manual during flight. That's another reason to be in control or communication with people on the ground, so that they can make sure that we're working through the different parts of the system. Before I get to that, real quick, other things that I'm using to make sure that this all works is a lot of research. And a lot of the research I've done has come so far on the life support system from two really important books. One is Principles of Bioastronautics by Siegfried Geratewohl. This is the principles of bioastronautics, and it goes through human tolerances, pressures, barometric pressures, all kinds of biological issues regarding flight. And particularly flight to high altitudes. Also very useful, I picked this up just a couple weeks ago, the NASA Bioastronautics Data Handbook, and this gives you the results of years of testing and so on, and gives you principles from which to work, basically. All kinds of information. And these help to identify, okay, what are the pressures I need and so on. And from those then comes for example, a pressure schedule. These are altitudes, and these are pressures that the suit needs to be set at to maintain me in good health during the flights. Another thing that I'm working on are checklists. I have checklists are really interesting. I want to write a book about the history of checklists. But for example, here's a pilot checklist for the B-17, World War II B-17 bomber. Well, you have to go through, even as capable as air crews are, there's just nothing to replace going through these checklists every time, piece by piece. And there have been air disasters caused by people skipping, of course, even just one piece of a checklist. So these are very important checklists, and they go through multiple iterations, working them out during the simulated flights, working out the different procedures that you have to go through. So checklists, obviously, awfully important, and they'll be a big part of the flight manual. Right now you can see that the flight simulation program is running, and I'll just show you that briefly here.